So there's a lot of ages being summarised in this stem and leaf plot. It shows the age of gamers who played Friends Join the Army. You know that show Friends? Well, they made a game out of it where they go in the army for an hour last Thursday, and they've summarised it there. Now, instead of having to write down 12, 12, 15, 15, 17, instead of having to write all that down, they decided that all of those numbers had the same stem. That was the 1 at the beginning of it, representing 10. And then the leaves would be the units digit. So the stem I'm pointing to here is a 1. That's the stem. And the leaves, or you could call each one a leaf, are these numbers, these units digits. Of course, if it was in the hundreds, then you might have a different stem. So you've got to decide what's reasonable for your stem and leaf to summarise the actual data you've got. But here, the ages, there were children less than 10 years old. There were children between 10 and 20 years old, and there was 20 up to 29 who were on that gaming situation. So what was the age of the youngest player? Well, the youngest player is here, 05, which is just 5 years old. What was the median player age? Now, remember with median, you line everything up from smallest to biggest, and then you go and you select what lies in the middle. If there's 2 numbers in the middle, you average them out. If there's 1 in the middle, well, that's great. Well, the good thing about stem and leaf plots is if they're made correctly, the numbers are already arranged from smallest to biggest. Like here, our age ranges goes from 5 years old up to 29 years old. This 9 here in the table, this 9, it means 29 because its stem is a 20, like it's a 2, but representing 20. So they're already lined up from smallest to biggest, so you can just cross out until you get to the middle if you want. For example, cross out the 5 and cross out the 9. That's 1 big one and 1 small one crossed. Then move in the 7 and that 27. So the 29 and the 27, sorry. Okay, then cross out the 12 because that's the next smallest number, and then cross out the 26 and cross out the next 12 and the 25 and the 15 and the 22. Now, if I cross out the 15 and the 21, it leaves me 1 number in the middle, and that's the 17. To be careful, not just 7, that number there is 17. Now, for there to be a single number in the middle, there would have been an odd number of scores altogether. If there's 2 in the middle that you need to average out to find the median, that means there's an even number of scores. Well, let's have a look. I'll just check there was an odd number of scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There were 13 scores. There was the first 6 scores, then our median score, which is our 7th score along, and then there were the next 6 scores to get me up to 13 scores. Why would this set of data be described as bimodal? Well, I'll just erase stuff out here so you can see the data a bit better. Why would it be described as bimodal? Because there's 2 modes. There are 2 modes. Bi means 2. A bicycle has got 2 wheels. A tricycle's got 3. There's 2 modes. They are 12 and also 15, because there's a 12, a 12, a 15, a 15. But they're the most common scores. All right, the following stem and leaf plot represents the ages of male and female athletes who attended Meet Your Favourite Olympian training session. The oldest male to attend was 28 years old. Now, this is called a back-to-back stem and leaf plot because it's there's data on the left and the right-hand sides, and they're sharing the same leaf in the middle. Now, judging by the ages, we know what the leaves mean. The 2 means 20. It's 2 lots of 10. The 1 is in the teens, 10, and the 0 means you're less than 10. So that youngest age there is 9 years old that attended that session. Well, the youngest overall is 0. It's not even a 1-year-old. You call it must be a baby. And why would that person have been at the training session? Maybe because one of the older ones was a mother or father that had to take the child there. And that's my answer to that question, a reason why that is 0. Now, but how do you know which side was male and which was female? Well, besides sort of seeing that as part 3 in the question gave that away, they said here the oldest male to attend was 28 years old. Now, that's 28 on that side. So that's the males. Now, if you say, but wait a minute, there's a 28 on the left side as well. Yeah, but that's not the oldest. Right? There's also a 29 there. So that would be the female side over here. So back-to-back stem and leaf plots are good for representing where you've got 2 different main groups within your group, like male and female. Or you might have, you've got a group of tourists, and some might be from Australia and some might be from New Zealand, and you want to summarise your data, and it's all in the one plot, but you've got the Australians on the right side and the New Zealanders on the left side. And so you have a stem and leaf plot you can compare those 2 groups. So I can compare the males and the females on this one. How old was the oldest female at the training session? 29. That's that one there. So 9, but means 29. Did males or females have the highest median age? Well, I'm going to cross out and find out what the median age for the males was. I'll just get a different coloured pen to do that. So crossing the smallest and the largest male, then the next smallest and the next largest, the 27 and the 11, then the 12 and the 25, then the 15 and the 24. Now, there's 2 left in the middle, so there must have been an even number of scores altogether there, right? So in the middle, I've got a 15 and I've got a 19. When that happens, I average them out. So the average of 15 and 19 is 17. So the males one is 17. And then if we do the females one, let's grab a nice French and purple for that. 9 years was the youngest and 29 was the oldest, right? The next youngest is 12 and then 28, 13, 24, 15 and 24. There's 2 in the middle as well for the females. There's an 18 and there's a 22. Well, you average those out and you get 20. So, do the males or females have the highest median age? Females did, right, with 20. And we've already said the youngest male is probably a baby that had to go along with somebody there. Dot plots. The number of hours spent watching television on a weekend is shown. Look at all this data here. Ridiculous to get some meaning out of it when it's all recorded like that. But if we put each of those data points on the dot plot, we can see a lot more clearly what's going on. So this first 3 here, right, it would be 3 hours. So it'd be the first one plotted there. Then the next 3 that's in that set of data would have been plotted on the dot plot there. And the next one that we came across would have been plotted there. And what's a good idea when you're plotting these is as you've plotted them, to cross them out so you don't double up or don't miss one, or if someone distracts you, you don't mess up the dot plot. So all that information's been put on the dot plot. What was the maximum number of hours spent watching television? Well, 8. Only one person did that. What was the most common number of hours? Well, there was 1, 2, 3, 4, 5, 6 people doing 3 hours. What is the median number of hours to watch television? So once again, if you want to, when the data's set out like that, you can cross out going from smallest to biggest. For example, we've got a 1 hour there with an 8 hour there, and a 1 hour there with a 7 hour there, and a 1 hour there with a 7 hour, 2 hours with a 6, a 2 with a 6, a 2 with a 6, a 2 with a 5, a 2 with a 5, and then a 3 with a 5, and a 3 with a 4, and a 3 with a 4, and a 3 crossing out with a 4. And so we've got 3 hours is in the middle. And when you average out a 3 and a 3, you get a 3. So the median number of hours was 3. Now, just to let you know what we've just done in the long way, if those hours were all written out in the long way, you'd have 3 1s in a row for the 1, the 1, and the 1. And then you'd have 5 2s. And then you'd have 6 3s. And then you'd have 3 4s. And then you'd have 3 5s and 3 6s. And then you'd have 2 7s. And then you'd have an 8. So if you line them all up from smallest to biggest, that's what you've got there. And what we were doing by crossing out from end to end, we were crossing out, the biggest score with the smallest, and the next biggest with the next one, and we were moving our way in to the middle, just symmetrically, like this. And really, if I had two pens and the coordination, I would cross at the same time, and I'm left with those 2, 3 in the middle. And 3 plus 3 on 2, that's how you average out 2 numbers, is 3, obviously. But it's easy to do from the dot plot that's given there. Grouped frequency tables. Sometimes there's just so many different numbers, and some aren't repeated, that if you made a frequency table which included all those individual numbers, it would be ridiculous, right? Now, I'm not going to, I know they're all not represented there, but it looks like it goes from 0, and the highest number is somewhere like, say, 34, right? So it's possible to have there's 35 different numbers that it could be there, right? So if you were going to set up a frequency distribution table and you had the scores here, right? You'd have 0, 1, 2, 3, 4, 5, 6, all the way down to 34. That's ridiculous, because some of them have only got, the number 1 there has only got 1, whereas the number 0 has got 1, 2, 3, 4, 5, 6, 7. That's got 7. But some of them are only represented one time. And the table would be a big, long table, and you're not going to really see much about your data. So what we do is we go, let's group the data into some reasonable type of groups. And I think here you could have 3 groups or 4 groups. You could go from 0 to 9, or you could go from 10 to 19 and 20 to 29 and 30 to 39 and do it that way. Or what I think might be more reasonable here, but it's always arbitrary. You've got to go with what's most reasonable. There's no rule. You just don't want to have too many groups, but then you don't want to have too few that you can't really see anything that's happening with the data either. So I think it was great to do it in classes or groups of 5, like 0, 1, 2, 3, 4 is the first group, and 5, 6, 7, 8, 9 is the second group, groups of 5. So you can see them here in our class column. So 0 to 4, 5 to 9, 10 to 14, 15 to 19, and you can work out what the class centres are. Because later, when we try to do mean from that, we need to know what the class centres are. And when we do histograms, we need to know the class centres. So to work out the class centres, you simply take the lower and the upper ends of each class and divide by 2. So that's why I got a class centre of 2 there. But this one is 5 plus 9 on 2. It's 14 on 2 is 7. So that's where I got a 7 from there. So now the data is all nicely placed in a table, and it makes a bit more sense than having every individual piece of data represented. Now, what does this tally column mean? Well, let's have a look just for the zeros that are there, what the tally column means. What we would have done is we would have looked at the first zero, right? We've used it up, so we put a tally mark. I'll write it there at the top of the tally column. I've put a mark for that first zero. Then the next zero, another one. Then the next zero, another one. Then the next zero, another one. And when I get to the next zero, if I've already got 4, I put 1 across to make a grouping of 5 that's easy to see. The next zero I come to, I put another one. The next zero, I put another one. And the last zero, I put another one. So you can see I've got 5 and 3, which is 8. Now, that's just the zeros, right? But that class was 0 to 4. So what I would have done as I was going along is tallied up, you know, also the 2. There's one there. And the 5. No, that's not between 0 and 4. Just joking you there. And the 3. Now that will make another grouping of 5. And the 1. And the other 2. So you can see that there's a grouping of 5, a grouping of 5, a grouping of 2. 5 and 5 and 2 is 12, and that's why the actual frequency as a number is 12. But you tally so you can make sure you get the stuff in the table correctly. What was the modal class? That's just another way of asking for the mode, but because we're not now got individual scores, we want to know what class the mode was. Well, which is the highest frequency? Clearly the 12 is the highest frequency. So the modal class is 0 to 4. That's the one with the most bits of data in it. If the classes that were chosen were 0 to 9, 10 to 19, 20 to 29, and 30 to 39, what would the class centers have been? Well, you just add up the edges of the classes and divide by 2. So 4.5. And this one would be 14.5 and 24.5 and 34.5. And yes, it cannot be a whole number. It's usually 0.5. It's usually that, or it's or a whole number. Can the actual mode or median be determined accurately from the table? No, it can't. Right? You can guess where it might have been, but you only know classes. So, you know, let's say there's 26 bits of data, so 13th one along would have been, if you line them up from smallest to biggest, the 13th and the 14th ones along would be the median, right? And so it's in here somewhere in the 5 to 9 range, because the first 12 scores are in the 0 to 4 range, and then the 13th and the 14th scores along would be in the 5 to 9 range. But are they 5s? Are they 6s? Are they 7s? Are they 8s? Well, you can tell. You can look in the data above, but it said in the question, can they be determined accurately from the table? No, I can only tell you the modal class, not the actual mode. And I can tell you what class I think the median is. And when we come to do cumulative frequency histograms and ogives, then we'll be able to get a little bit more accurate an idea of where we think the median might lie. But we still, the answer is no.